It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Your rating.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Welcome to Unacademy and welcome to Unacademy semester exams and welcome to Path Systems by CL Vadva MCQs backside bits objective type questions from 301 to 350. We'll discuss the solutions as a part of this lecture 7. So Augustus, good evening, welcome to Unacademy. So let me tell you about myself. I am Vai Shravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services and also cracked GATE. Unacademy, let's crack it and crack GATE and ESE with India's largest learning platform and get subscription. You can also install Unacademy learning apps and get subscription. You can get these things: daily live tests, structured courses, live test and quizzes, unlimited access, personal coach, study tracker, mains question and answer, all benefits in Iconic subscription. And in Plus subscription you have daily live classes, structured courses, live test and quizzes and unlimited access. You can learn from the top educators of the Unacademy, as you can see, and also GATE and ESE year-long batches, and for all the branches with all the subjects you have many courses for each and every specialization. And you have Plus and Iconic subscription. In Iconic you get all the benefits of the Plus along with some special benefits you can see. And in Plus subscription, for the Plus subscription you can use my code YSK10. I prefer 24 months and suggest you to go for the 24-month subscription. You can use my code to get the maximum discount, and this discount will be only for few more days and you should be ready to get subscription, and the things are going to change. Also in Iconic subscription you can subscribe for 24 months, get subscription to 24 months. You can use my code YSK10 to get the maximum discount and of 10%, and this will be valid till a certain period of time, and there will be a change of discounts also. Now today's Path Systems by CL Vadva MCQs from 301 to 355. Let's look at the questions and their solutions. So guys, share with everyone and ask everyone to watch the session, which will be very much useful for your upcoming exams. So control rods, let's look at 301 question. The control rods used in the nuclear reactors are made of. So what are these control rods required for? These control rods are required for the control of fission process. So you can say that as we know, control rods are basically made of boron. So the answer to this question will be boron. right? Now let's look at the next question. Let's look at the next question. Consider two parallel short transmission lines. So consider two parallel short transmission lines of impedances ZA and ZB respectively, and this is shown in this figure. You can see ZA and ZB. Yeah, this is ZA and ZB. And currents IA and IB both are lagging, and sending end voltage is VR. So this is the sending end voltage. Let's try to crop this so that we can use it in the same slide. Yes. Now look at this. This is a question. Yes, this is the 303 question diagram. So you can see these are the impedances. And so you can just consider them. VR is the sending end voltage. If the reactance to the resistance ratio of the impedances is ZA and ZB, then the total current what happens to this total current? We know that the currents IA and IB for a parallel transmission lines X by R ratio will remain same. So as the X by R ratio remains the same, you can easily find the rest of the things. Let's move on to as you can find, X by R ratio is same for both the lines, for parallel lines, you know that. So it will be easy for us to find the penalty factor, and also you know this currents IA and IB will be in phase with the feeder current. So feeder current, therefore you can say ultimately the answer is, where is that? First is lag both IA and IB, lag one of IA and IB but lead the other, lead both be in phase. So you have found this question answer. This is the be in phase with IA and IB. So the answer to this question is D. What is that? It is D. Now let's go back. Let's go to the 303 question number. In a three-phase extra high voltage cable, EHV cable, a metallic screen or a metallic paper around each core insulation is provided to. What do you provide? A metallic paper. So it is to facilitate heat dissipation? No. It is to give the mechanical strength? Not. Obtain radial electrical stress? Yes. And obtain longitudinal electrical waves? No. So you can say that in a three-phase EH voltage cable, a metallic paper. What do you need a metallic paper? We need this around each core insulation so that to obtain the radial electric stress. It is to obtain the radial electric stress. So 303, the answer is C. Next, let's go to the 304th question. Galloping. What is galloping? It is nothing but the swinging of the parallel lines, swinging of transmission line between towers. Due to, it can be due to like wind. If there is some wind, it will swing, or due to, that is also called something like it's moving due to wind. A transmission line, that is termed as the galloping. When a transmission line arises generally due to, why does this happen? You can see that asymmetrical layers of ice formation, vortex phenomena in light winds, heavy weight of the light conductors, no. Adoption of horizontal conductor configuration. And why does this happen is because of the non-uniformity. So you can see asymmetrical layers of ice formation. This can be the answer. So because of that non-uniformity, this swing will happen. That is, the answer is A, asymmetrical layers of the ice formation. Now let's look at this 305, question number 305. In a matrix form, equation of a 4-terminal network representing is given by this. BSIS is equal to ABCD and VR and IR. The two networks are, this is one, you can see this, This is y and this is z. Yes. So the possible transfer matrix for the networks A and B could be. So if you look at this, this is 1 plus, if you look at these options, you can look at these options. The first option says it is 1, YZ, 0 and Z, and the other one is Y0, YZ and 1. But if you look at this, the correct combination of the two networks A and B could be, can be, this cannot be the answer. You can see this cannot also be the answer to this. And if you look at this, this is Z and Y, this is Z and Y. So it can be 1 Z, Y and 1 plus YZ and 1 plus YZ, Z, Y and 1. This is a possibility that we have. So 3 and 4 are correct. So the answer is D. So the answer to this question is D. Now let's look at the next question, 306. The incremental generating cost of two generator units are, the incremental generating cost of the two generating units are given. What is that? IC1 is equal to 0.1x plus 20 and IC2 is equal to 0.15y plus 18 rupees per megawatt hour, where x and y are powers in megawatt generated by the two units for a total demand of, what is the total demand given? The total demand is 300, that is P1 plus P2, or you can, because it is x and y, you will write it as x plus y is equal to 300. So when x plus y is equal to 300, let's take IC1 is equal to IC2. So make IC1 is equal to IC2, 0.1x plus 20 is equal to 0.15y plus 18. And if you can solve this, you'll get the value of x as 172 megawatts and y as 128 megawatts. So it is 128 and megawatt in x and y will be. Hello sir. Good evening Shivakumar. Karthik, good evening. Arun Tej, hi. Word start. Hello. Yeah. So what is that? You get the value of x as 172 and y as 128. So the answer to this question is A. So it is A. Right. Now let's look at the next question, 307. Consider the following statements to provide reliable protection for a distribution transformer against over voltages using lightning arresters. It is essential that lead resistance is high. No. The distance between the transformer and the arrestor is small. Yes. Correct. The transformer and the arresters have a common interconnecting ground. Yes. This is also correct. The spark voltage of the arrestor is greater than residual voltage. Yes, the spark voltage must be greater than the residual voltage for the protection. So first is wrong, second, third, fourth are correct. So the answer is C. So this answer to this question is C. Now 308, let's look at the question 308. The reflection coefficient of a short circuited line for the voltage is. So reflection coefficient is gamma is equal to ZL minus Z0 by ZL plus Z0. Short circuit, if this is the transmission line, this is the short circuit. What is short circuit impedance? This is Z0, ZL is equal to 0. So this will be ZL minus Z0 by ZL plus Z0. That is ZL is equal to 0 minus Z0 by 0 plus Z0. It is minus 1. So 308, the answer is A. So the answer to this question 308 is A. Now let's look at the 309th question. The propagation constant gamma is of a transmission line is given as it is given as 0.15 into 10 power minus 3 plus j 1.5 into 10 power minus 3. Now the wavelength lambda is what? Lambda is equal to what? 2 pi by beta. 2 pi by, you need to find beta. What is beta? This is gamma is equal to alpha plus j beta. So this will give you beta is equal to 1.5 into 10 power minus 3. So it is 2 pi by 1.5 into 10 power minus 3 will give you lambda is equal to, that is given already, this directly that is given. So the answer is B. It is B. 309, it is B. 310, the hollow conductors are used in transmission line to reduce the weight of the copper. No, hollow conductors we use for reducing corona, right? So you know, you can find this. So let's see the options: reduce weight of the copper, improve stability, or reduce corona, or increase power transmission capacity. So the answer to this is reducing corona. So the answer is C. So C, hollow conductors are used for the reduction of corona. Now let's look at this 311th question. In the solution of load flows, NR method, Newton-Raphson method is superior to Gauss-Seidel method. Why? You can say that in NR method we require less number of iterations, right? Less number of iterations, whereas in Gauss-Seidel we have more iterations. Okay. Time taken to perform one iteration, yeah, the time taken to perform one iteration in Newton-Raphson is less when compared to the time taken in Gauss-Seidel. Yes. And number of iterations required in Newton-Raphson is more compared to that in GS method. Number of iterations required is not independent of the size of the system in the Newton-Raphson. And also there is one more option. The convergence characteristics of Newton-Raphson method are not affected by the selection of the slack spas. This is the major point. This is very important. This is also, it is independent. So Newton-Raphson method, it is independent of the selection of slack bus. So you can say that because it is independent of the selection of the slack bus. And also Newton-Raphson method is applicable for a large network, whereas Gauss-Seidel is applicable for a smaller network. So the answer to this question is D. Convergence characteristics of Newton-Raphson are not affected by the selection of the slack bus. It is independent of the slack bus. Next, 312. A power system network consists of three elements. 0 to 1. Let's consider that. Let's call this as 1, 2 and 0. 0 to 1, 1 to 2, 2 to 0, 1 to 2, right? The impedances are the per unit impedances are 0.2. 0 to 1 it is 0.2, and 1 to 2 0.4, and from 2 to 0 it is 0.4 again. So per unit impedance, the bus impedance matrix is. So first let's try to find the admittance. So Y is equal to, so let's write Y11, that is 1 by 0.4. This is 2.5. So you can write this as 1 by 2.5 plus 5. So this is 1 by 2. What is 1 by 2? Let's write these values first. So let's take 1 by 0.5 is 2.5, and 1 by 2 is 0, sorry, it is 5. 1 by 2 is 5. So 5 plus 2.5 will give you 5 plus 2.5, is Y bus matrix, it is 7.5. And between Y12 it is 2.5 minus, and Y21 minus 2.5, Y22 it is again 7.5. So if you just take the impedance matrix of this, Z is equal to, just take 1 by AD minus BC, 1 by 7.5 into 7.5 minus of minus plus of minus minus again. So you'll get a minus of 2.5 into 2.5. Soumya, good evening. Swarnasri, hi. Welcome to Unacademy and Power Systems CL Vatva MCQs. And D minus B minus C A 7.5. Now if you do this Z, so Z will give you, this is 0.16, 0.08. If you just simplify this, you'll get this 0.08, 0.24. So it is 0.16, 0.08, 0.08 and 0.24. The answer is B. Now the answer to this question is B. So here the answer is B. Let's check that once again. So the answer is B. Now let's look at the next question. 312 is done. 313. Zero sequence currents can flow from a line into a transformer bank if the windings are. If the windings are, it should have a star with a ground, right? So let's try to look at this. You have a star and a ground, grounded star, and grounded star and star. This is star and star, so invalid. So you do not find any grounded star here. So the only option is A. So the answer to this question is A. Answer to this question is A. Now let's look at the next question. Is A. 314. When a line to ground fault occurs, LG fault occurs, current in a faulted phase is 100 amperes. Current in a faulted phase is 100 amperes. There is zero sequence current in these cases. You can just directly write 3 times of IA is equal to 100 amperes. That's what is given. LG fault, 3 IA is equal to 100 amperes. So what is IA is equal to 33.3 amperes. So the answer to this question is, you can say it is B. B is the answer. Now let's look at 315 question. When a 50 MVA 11 kV 3-phase generator is subjected to a 3-phase fault. The fault is 3-phase fault. The fault current IF is equal to minus J5 ohms. Minus J5 per unit. Amperes per unit. Per unit, it's given in per unit system. When it is subjected to a line to line fault, LL fault, 3-phase fault, NL fault, the positive sequence current is minus J4 per unit. The positive and negative sequence reactances are respectively. You need to find the reactances. So first let's try to find what is fault current IF is equal to. It's equal to ER by X. What is the voltage? It is 1 per unit. We are taking it, and this IF is given as, let's write that value first. IF is given as 0. Sorry, it's 5, right? Fault current. So it is 5 is equal to 1 per unit by X. I'll call this as X is equal to 0.2. right? Now let's find yeah. Now let's try to find for LL fault. So for LL fault, IR is equal to ER by x1 plus x2. So this is 4. IR is equal to 1 by x1 plus x2. So what is x1 plus x2 value? We'll get it as 0.25 per unit. So this will be x1 is 0.2 per unit. So x2 will be 0.05 per unit. So for an LL fault, the positive sequence current and the positive sequence and negative sequence reactances are x1 is 0.2, x2 is 0.05, right? So this is A. The answer to this question is A. Now let's look at the next question. 316. The power generated by two plants is given. So P1 is equal to 50, P2 is equal to 40. So P1 plus P2, and there is something that's given. What is that? B11 is given, and the loss coefficients B11 is 0.001, B22 is 0.0025, B12 is 0.0005. The power loss will be, what is the power loss is equal to? Power loss is equal to B11 P1 square plus 2B12 P1 P2 plus B22 P2 square. So P loss will be, just substitute these values, we'll get 4.5 megawatts. You need to remember this. So it is answer C. So 316 answer is C. Alright, next 317. Let's move on to the 317th question. The following data pertain to two alternatives working in parallel and supplying a load of 80 megawatts. Two alternators. It is actually two alternators working in parallel, that is P1 plus P2 is equal to 80 megawatts. So machine 1 40 megawatts with 5% regulation, 60 MVA with 5% speed regulation. So you can write P1 into 5 by 100 40. What is that? Is equal to P2 into 5 by 60. P1 into 5 by 40 and P2 into 5 by 60. So that will give you P1 by P2, just cancel this. That will give you 2 by 3. Implies P1 is equal to 2 by 3 P2. So we already know P1 plus P2 is equal to. So P1 plus P2 is equal to 80. P1 is equal to 2 by 3 P2. 2 by 3 P2 plus P2 is equal to 80. So P2 value will be 48 MVA and P1 value will be 32 MVA. So the answer to this question is 32 megawatts and 42 megawatts. So D. So the answer to 317th question is D. Let's look at the 318th question. The per unit impedance of synchronous machine is 0.242. If the base voltage is increased by 1.1 times, then the per unit value will be. So what is that? Z per unit new is equal to Z per unit old into MVA new by MVA old into KVA old by KVA new whole square. Substitute this. Now what do you get? Z 0.242 into the 2 MVAs is 1.1 per unit and KVA 1 by increased by 1.1 times. So this is whole square. So Z per unit new is equal to, you'll get 0.2 per unit. You'll get 0.2 Raju, good evening. Welcome to Unacademy. This is the answer. So, what is the answer to this question? It is 0.2 per unit. It is 0.2 per unit. Now, let's look at 319th question. The following figure shows the single line diagram of a power system. Yes, with all the reactances marked in per unit on the same base. The system is on no load when three-phase fault occurs on F and the high voltage side of the transformer T2. The fault current will be. So how do you calculate the fault current? Let's look at the question once again. The following figure shows the single line diagram of a power system with all reactances marked in per unit. So let's write these values. So it's given. So this is a generator, a motor, and it's given transformer T1, transformer T2, T1 J 0.08 per unit, T2 0.08 per unit. So you can write this as 0.1 plus 0.08 J plus 0.2 J, 0.1 plus 0.08 J plus 0.2 J. That will be equal to J 0.38, J 0.38. Now what is that? 0.1 plus J 0.08 will be J 0.18. Now parallel the reactance. Now parallel this reactance. So 0.38 into 0.18. The 0.38 and 0.18. J 0.38. 0.38 into 0.18 by 0.56. This will give you J 0.122. So the fault current is IF. Fault current is E by X. What is E? 1 per unit by X is 0.122. So it is minus J 8.1871 per unit. So this is what we have calculated. So the answer to this question is J minus J. C. So 219th question, the answer is C. Now let's look at the next question. 320. A rated breaking capacity MVA of a circuit breaker is equal to breaking capacity of a circuit breaker. Breaking capacity of circuit breaker is equal to. So it is rated breaking current into rated voltage. So kiloamperes and this is kV. So it is a product of rated breaking current and rated voltage. So the answer to this question is A. Now let's look at the next 321. If in a short transmission line, resistance, inductance are found to be equal, the regulation appears to be 0, then the load will be. So it is a short transmission line. So we can write voltage regulation is equal to percentile cos phi, percentile R cos phi, right? So this is percentile R cos phi plus percentage X sin phi. So what is that? We'll get voltage regulation is given as 0, appears to be 0. Then 0 is equal to percentage R cos phi plus percentage X sin phi. It can be plus or minus. Now just try to equate them. 0 is equal to, so the inductive reactance. So you can further write this as percentage R cos phi is equal to X sin phi plus or minus, right? So if this is the case, what do you get? Phi is equal to 45 degrees or 0.707 leading. 0.707 leading. So the answer to this question is C. 0.707 leading. 322, a hydel power plant runoff river type should be provided with a pondage so that the operating head is controlled, no. Pressure inside the turbine causing remains constant, no. Kinetic energy of the running water is fully utilized. See, whenever you have a hydro power plant runoff river type, it should be provided for pondage so that what will happen? It will firm capacity of the plant is increased. So the answer is A. Now, 323, if within an untransposed three-phase circuit of transmission line, the series impedance of each of the conductor is considered, it is found to be contain resistive terms of the form K log D12 by D13. K is being constant and D12, D3, etc. being spacing between the conductors. What are D12, D13? Spacing between the conductors. These terms represent power transfer from one phase to the other. The sum of these terms over the three phases. The sum of these terms over the three phases will be. So we are given an untransported three-phase circuit of transmission line with some series impedances of each conductor. Then they represent the power transfer from one phase to the sum of these term over three phase. So if you just add those three terms, these terms, the series K log D12 by D13, and because D12 and D13 are the spacing between, these terms represent power transfer. So the power transfer from one phase to the other. If you add these terms, then the power transfer will become 0. That is nothing but, so the answer to this question is 0. It is D. These terms represent power transfer, so from one phase. The sum of these terms will be over three phases will be obviously 0. Now, match the following 324. So percentage power loss in transmission line, it corresponds to percentage power loss will decrease with system voltages, right? So it will decrease with system voltages, and for a given current density the conductor size will increase with line length. And for the power handling capacity of a line at given voltage, the power handling capacity of a line at given voltage, it will reduce with the line length, power handling capability. And the surge impedance of the transmission line remains independent of the line length. So you can say A matches to 1, B matches to 4, and C matches to this. So let's see, A is 1, B is 2. This is wrong. A is 1, B is 4. This is right. So the answer to this question is D. So the answer to this question is D, 324. Now let's look at 325. Expanded ACSR are conductor composed of large diameter individual strands. So the conductor of large diameter can be obtained aluminum strands here, and large diameter of central sheet strands for a given all over diameter, large diameter of aluminum strands for a given all over diameter, a filler between inner and the outer aluminum strands to increase the overall diameter of the conductor. Now if you observe this, so the extended ACSR are conductors composed of, they are composed of large diameter individual strands, no. Large diameter central steel strands, no. Large diameter of aluminium, no. A filler with inner steel and an outer aluminium, yes. It will have a filler in the inner steel and an outer in the aluminium. So generally you can say the conductor of larger diameter increases the effective diameter of the conductor so as to reduce corona loss. So what will happen? Corona loss will reduce. Hence the radio interference level will also reduce. So filler between the steel and the outer aluminum strands to increase overall diameter of the conductor is the correct one. So you can say the answer is D. So the answer to this question is Srinivas. Welcome to Unacademy. Now let's look at the next question, 326. Which of the following are the advantages of interconnected power systems? Interconnected operation of the power systems. Less reserve capacity, more reliability, high power factor, reduction in short circuit level. No? So let's look at the answer. Interconnected power system. What are the advantages of interconnected power system? You can say less reserve capacity, yes. More reliability, yes. High power factor, no. A reduction in short circuit level, no. So we can say for a interconnected power systems, the answer is 1 and 2. Yes. So 1 and 2 are the correct. So the answer to this question will be yeah. Now let's look at the next question 327. Steady state stability of a system is improved by. Steady state stability of a system is improved by reducing clearing time, no. Single pole switching, no. Double using double line instead of single, yes, this can be. Decreasing generator inertia, no, this cannot be. So you can say the answer to this question is B. Using double circuit line instead of single circuit line, stability can be improved. Steady state stability can be improved by using double circuit line, and transient stability can be improved by single pole switching. Transient stability can be improved by single pole switching. Next 328. Equal area criteria gives the information regarding. Equal area criteria will give the relation regarding stability region, absolute stability, relative stability, swing curves. Equal area criteria gives the information about the absolute stability. It gives the absolute stability of the. So that is B answer. Now 329 question. With the number of generators of MVA capacities S1, S2, S3 and so on Sn, and inertia constants H1, H2, H3 and so on Hn, respectively connected to same bus in a station, same bus bar in a station, the inertia constant of equivalent machine on a base of SB will be. So on a base of SB you can say, so it is inertia constant is S into H. Now if the base is given, you can write summation of I is equal to 1 to n SI by SB into HI. So the answer C is correct. You can say, so the answer to this question is C. Now let's look at 330. Critical clearing time of the critical clearing time in a power system is related to. Critical clearing time is related to transient stability. So it is critical clearing time relates to the transient stability of the system, that is D. Now the use of fast acting relays and circuit breakers for clearing a sudden short circuit on a transmission line link between generator and receiving end bus improves the stability of the machine because the short circuit machine post fault transfer impedance trains a value higher than during the fault. Ordinate of the post fault power angle characteristics is higher than that of the during fault characteristics, no. So you can say, yeah, so this is correct. This voltage behind the transient reactance increases to the higher value, no. So use of fast acting relays and circuit breakers for clearing a sudden short circuit between generator and the receiving end improves transient stability because the ordinate of the post fault power angle characteristics is higher than that of the during fault characteristics. That is the correct answer. So 331 C. Let's look at 332. Consider the following statements. The transient stability of the power system under balanced fault conditions can be effectively improved by under unbalanced fault conditions. Transient stability of the power systems can be improved by excitation control, phase shifting transformer, single pole switching, and increasing the turbine. So just now I told you, we have discussed that using transient stability can be improved by single pole switching of the circuit breakers, or you can also increase the input of the turbine. But phase shifting transformer or excitation control does not affect this. So answer 3 and 4 is correct. So the answer is C. So the answer to this 332 question is C. Now let's look at the next question. 333. The non-uniform distribution of voltages across the units in a string of suspension type insulators is due to. So this is due to the stray capacitance, right? It is a non-uniform distribution of voltages. We have already seen this. This is due to the shunt stray capacitance. So unequal self capacitance, no, and non-uniform distance of separation of no. Tower body, the existence of stray capacitance. Yeah, this is the answer. So non-uniform distance between the, no, this cannot be the answer. So the answer to this question is the existence of stray capacitance between the metallic junctions of the units and the tower body. This is the correct one. So the answer is C. Now let's look at 334. Whenever the conductors are dead end or there is change in the direction of the transmission line, yeah, insulators are made of. So whenever there is a dead end or there is any directional change, you'll go for strain type of. Strain type is used basically. So at the dead end or the direction is changed, you will go for strain type of, it is a strain type of insulator. Now let's look at the next question, 335. Consider the following statements. In case of a suspension type insulators, string efficiency can be improved by. In case of suspension type insulators, you need to improve the string efficiency. So you can use longer cross arm, yes. You can use guard ring, yes. You can use it. You can use grading the insulator discs, yes. Reducing the arm, no. Cross arm length, no. So 1, 2, 3 are correct. So we can say this is the right answer. So 335, the answer is A. So string efficiency is given by voltage across the string by the N into voltage across the unit near the power conductor. So N is the number of insulators. N is the number of insulators. So for equalizing potential, what do you do? Use long cross arm, yes. Also use guard ring and a static shielding, or you can call it as a grading insulating discs. So the answer to this question is 1, 2, 3 are correct. So A is the answer. Next, 336. In a power system, each bus or node is associated with 4 quantities, namely real power, reactive power, bus voltage magnitude, bus end of the bus, phase end angle of the bus voltage. For a load flow solution, among 4, number of quantities to be specified. Any 2, so it must be 2 quantities must be specified for calculating the remaining 2. So the answer is 2, B. Now let's look at the next question. 337. Match list 1 and 2 for the production of. Select the correct answer using the codes. List 1, Buckhouse relay, trans relay, negative sequence relay, directional overcurrent relay. So you know that Buckhouse relay is related to transformer, and trans relay, you know it for a feeder, and negative sequence relay is for a generator, and directional overcurrent relay is for the overhead lines. So answer is, what is this? This is 1, sorry, this is 2, 1, 3 and 4. So 2, 1, 3, 4, answer B. So the answer to this question is answer B. No, 338. Next question, look at the next question. A line trap in carrier current relay tuned to carrier frequency presents. This we have seen line trap in the previous session also. The carrier frequency has high frequency, so it has high impedance. So the carrier frequency will have high frequency. So because it has high frequency, it will have low impedance. Right? So you can write the answer as a low impedance to both carrier and power frequency. 338. Low impedance to both carrier and power frequency. Next, look at the 339. In the basic circuit of circulating current protection is shown in the figure. To improve through fault stability, a stabilizing resistor is connected between the points. You need to connect a resistor, stabilizing resistors between. You need to connect. If you just try to connect it somewhere, just try to connect it here, or you need to connect it between these 2 points. Or so if you look at this, if you connect this here, then to improve the fault stability, you can connect it between R and P. So answer is A. So answer to this question is A, between R and P. We can say that between R and P you connect it. Now look at the next question, 340. One CT is mounted over 3-phase 3-core cable with its sheath and armor removed from the portion covered by the CT. An ammeter in the CT secondary would measure. So ammeter in the CT secondary would measure. So 340. So one current transformer is mounted on 3-phase and 3-core cable with sheaths and armor removed from the portion covered by the CT. It's 3 times the zero sequence current, right? So it is 3 times the zero sequence current. So answer is D. 340. Answer is D. Now let's look at the next question. In the connection with extension in circuit breaker, resistance switching is employed, wherein resistance is placed in parallel. Yes, this is placed, as we know, with poles of the circuit breaker are shown in the figure. This is the circuit breaker. This process introducing damping in LC circuit. For critical damping, the value of R should be. We know that the value of R should be, we already know, as I told you in the previous classes, 1/2 root L by C or 0.5 root L by C. So the answer is C. So answer to this question is C. Now let's look at the next question, 342. Load frequency control is achieved by properly matching the individual machines. So load frequency control is achieved by matching turbine inputs. Load frequency control, we know that it's by matching the turbine inputs. It is achieved. So answer is C to this question. We already know turbine inputs are important. So if the voltage controlled bus is treated as load bus, we are treating it as load bus, then which one of the following limits should be violated? Which one of the following limits should be violated? So reactive power, because it is being treated as a load bus, you can violate this reactive power. So the answer to this question 343 is C. Now 344. The self-inductance of long cylindrical conductor due to internal flux linkage is K Henry per meter. If the diameter of the conductor is doubled, you are increasing the diameter. then the self-inductance of the conductor due to its internal flux linkage would be, if the diameter is doubled, then it does not affect this, right? So it is K Henry per meter. So answer B is the correct one. Now let's look at the next question. Two arrangement of conductors are proposed for a three-phase transmission line. One for the equilateral spacing of 4 meter, other flat with 4 meter between the conductors as shown in the figure. So this is flat with 4 meters and this is equilateral equispacing with 4 meters. The conductor diameter in each case is 2 centimeters. Conductor diameter is 2 centimeters. Assuming that the line is transposed in both the cases, you are transposing in both cases, which of the following cases statements is true? So you can see this in this case. So Cn1 is greater than Cn2 as given, and in this case you can see L1 is less than L2. So symmetrical to unsymmetrical transpose. So you can say that the answer is B, right? Answer is B, but it is C1, L1 is less than L2, I guess. So next, look at the next question. For a given power delivered, if working voltage of a distribution line is increased to n times, so the cross sectional area of the distributed line would be reduced to 1 by n square terms. So the power delivered, for a given power delivered, working voltage of a distribution line is increased voltage. Cross sectional area is 1 by n square of A. So the answer is B. Right, now let's look at the next question. 347. The following sequence currents were recorded in the power systems under fault condition. It is J, positive, negative and 0. The fault is, just by looking at this, if you just add this, I positive plus I negative plus I 0, you will get 0. So it is LLG fault. So LLG, line to ground. So the answer to this question is C, 347 C. Let's look at the next question, 348. When bundled conductors are used in place of single conductor, the effective inductance and capacitance will. So you can say L is proportional to GMD by GMR and C is inversely proportional to GMD by GMR. So just by looking at this, you can say that let's say you have L1 and L2 is proportional to GMD by GMR and C2 is proportional to 1 by GMD by GMR. Now you can say that in place of single conductor you are using bundle conductors, so L2 is less than L1 and this is C2 is greater than C1. So answer is, so the effective inductance will decrease and the capacitance will increase. So capacitance is increasing and inductance is decreasing. So the answer to this is B. So 349, a balanced three-phase three-wire supply feeds balanced star connected resistors. If one of the resistor is disconnected, then the percentage reduction in load will be 50%. So we have already seen such things. So it is B. So the answer to this question is B. It is 50%. It is 50%. Now let's look at the next last question for today. A long overhead transmission line is terminated. A long overhead transmission line is terminated by its characteristic impedance matching. Under the operating conditions, the ratio of voltage to current at different points. See, this is ZL is equal to Z0. So then the voltage to current ratio will remain same at all the points. So it is D because it is a matched line. So this will be D. So the answer to this question is D. So today we have seen the power systems by CL Wadhwa MCQs 3012 350. As I always tell you, we have India's #1 study channels on Unacademy. Do like the video and share the video, and also comment and subscribe to Unacademy and subscribe to YS Unacademy's semester exams. Use my code YSK10 to get the maximum discount. And this offer is only for few days, and click on this bell icon to get more notification of my classes. You can also join us on Telegram for the latest updates. And I wish you had a great session, and thank you once again for joining me today on the Power Systems by CL Wadhwa MCQ Solutions from 3012 350. Thank you so much.